one of the most fascinating topics in modern physics, the Higgs boson, which was famously called the God particle by Leon Lederman in his book of the same name. But first, let's clear something up. The Higgs boson is not, in fact, the God particle. In point of fact, quite a few physicists find the nickname a bit cringeworthy. The term God particle was coined by Lederman not because the Higgs boson was any religious connotations or because it can explain the mysteries of the universe, but simply because publishers of his book thought it would be a catchy title. From mind-bending theories to mind-blowing discoveries, join us as we explore the cutting edge of science and push the boundaries of our understanding. So what is the Higgs boson and why is it such a big deal? In any case, in order for us to fully understand this, we will have to go into the realm of particle physics and analyze the Standard Model. The Standard Model is a theoretical framework that represents the basic elements of matter as well as the interactions between them. The Standard Model states that matter is formed by the subatomic particles known as fermions. These particles, which also include quarks and leptons, are said to be defined by four basic forces: gravity, electromagnetism, and the strong and weak nuclear forces. On the other hand, the Higgs boson is a particle that is associated with the Higgs field, which is a hypothetical field that goes through all space and gives particles their mass. The Higgs field was first suggested by Peter Higgs in 1964. Particles would not have mass, and the universe as we know it would not exist if it were not for the Higgs boson and the Higgs field. To argue that the discovery of the Higgs boson was one of the most major breakthroughs in physics in the previous century is not an exaggeration, despite the fact that it may seem like an overstatement. In 2012, researchers working at the Large Hadron Collider, the LHC in Switzerland, claimed that they had discovered a new particle that had characteristics consistent with those of the Higgs boson. This finding is the culmination of decades' worth study, both theoretical and experimental, that was contributed by hundreds of researchers from different countries all around the world. But how can we be certain that the particle found by the LHC is in fact the Higgs boson? Well, that's a great question. Let's go deeper into how scientists made this conclusion. The identification of the Higgs boson was not a simple task. Instead, it required a significant amount of time, as well as careful research and experimentation. The LHC generates an incredible quantity of data, and sorting through it all to find the signal of the Higgs boson was like looking for a needle in a haystack. The Higgs boson is an extremely uncommon particle, and the only way to establish its existence is to look for its products of decay. When collisions occur in the LHC, the Higgs boson is generated. However, it swiftly decays into other particles such as photons, W and Z bosons, and fermions. The detectors at the LHC are able to pick up on these particles and record both their energy and their momentum. However, the signal from the Higgs boson's decay products is very weak, and it is hidden behind a massive background of other particles that are created in collisions at the LHC. This is because the signal is buried beneath an immense background of other particles. Because of this, researchers had to devise complex methods of analysis in order to separate the signal of the Higgs boson from the disturbances. At the LHC, one of the most important methods of analysis that the scientists utilized was to search for an excess of events in the mass range where the Higgs boson was expected to be. In addition, the researchers investigated the characteristics of the decay products of the Higgs boson, such as their energy, momentum, and angular distribution, to verify that these qualities were in line with the predictions given by the Standard Model. I would like to remind you to hit that like button and subscribe to my channel for more fascinating content like this. In 2012, the scientists made the announcement that they had discovered a new particle that seemed to be the Higgs boson after doing an analysis of the data obtained from the LHC. The discovery of the Higgs boson was a triumph of modern physics, which verified the existence of the Higgs field. The Higgs field gives particles their mass, and the boson is accountable for that mass. In addition to this, it offered substantial support for the Standard Model, which is now the most successful theory in the field of particle physics. However, the discovery of the Higgs boson also raised many new questions for physics to explore. For example, the Higgs boson is only one of many particles predicted by the Standard Model, and physicists are now searching for evidence of new physics beyond the Standard Model. In conclusion, while the Higgs boson may not be the God particle, it is undeniably one of the most significant discoveries in the history of physics. Our understanding of the fundamental nature of matter and the world as a whole has been enhanced as a result, and it has opened up new avenues of research for physicists to explore. Thank you for watching this video, and I hope you enjoyed learning about a Higgs boson. If this was interesting to you, your next video should be this one. Thank you for watching and keep exploring.